program properties. There are several properties of executable formats of programs that can be run on a computer. One. Relocatable. A program is read into main memory from auxiliary storage. A program that can be executed no matter where it is located in main memory is called a relocatable program. For example, variables used in the program are expressed by name in the source code. However, in the executable format, load module, they are all expressed as addresses or values. In the case where these addresses are expressed by direct addressing, if the location of the program changes when it is loaded into main memory, it will not be executed correctly. In a relocatable program, the expression of addresses specified in the program needs to be done using relative address from the beginning of the program. This type of addressing system is called base addressing. The starting location of the program is set as the base register when it is loaded into main memory. Two. Reusable. When a program, or module, that has been used for another task exists in main memory, it is not necessary to load it again from the auxiliary storage. The program already existing in main memory can be reused. This is the reusable property. If a variable has an initial value and the program changes its value, the value of the variable will not be restored to the initial value at the end of execution. Because of this, if another task uses it as the original, or initial, data, correct processing cannot be done. For example, in the case of a program, or module, for counting something in which the count is returned when it is finished, the variable value will be the resulting value. Therefore, if the module is used again by another task, the processing result will become the final count of the last time, plus count of this time. A reusable program would avoid this by resetting the variable to the initial value when it finishes processing. A reusable program becomes reusable only after the task using this program is completed. This means that when the program is being used by another task, the task that wants to use it has to wait until the other task using it is finished. In order to emphasize this, it is sometimes called serially reusable. Three. Reentrant. A program that can be used even while another task is using it is called a reentrant program. It is a program that can return correct processing results even when shared by multiple tasks. The program is made up of two parts. One part is a variable part where the content changes during execution. The other part is the instruction part where the content does not change during execution. When multiple tasks share the program, this variable part becomes a problem. For example, tasks A and B share a reentrant program. The variable content of processing for task A and task B are not the same. If the program confuses this, neither of the tasks will get a correct processing result. The Reentrant program has a mechanism to solve this. The typical solution to this is to divide the program into an instruction part and a variable part. Only the instruction part is shared, and the variable part is prepared separately for each task. (4) Recursive. A program that has the capability of calling itself is called a recursive program. The example often used to explain recursion is the factorial calculation. The factorial of integer n is the multiplication of the integers 1 through n, and is written as n with exclamation mark. In other words, factorial n equals n times n minus 1 times n minus 2 times, and so on, times 2 times 1. By looking at this expression, you can see that it is factorial n equals n times factorial of n minus 1. By using the recursive property, the program, function n, that is given the integer n, and returns factorial n, can be expressed as follows. Function n. If n equals 1, then 1 else n times function of n minus 1. Let us look at this program's operation for n equals 3. 1. If n equals 3, then 3 times function of 2. 2. If n equals 2, then 2 times function of 1. 3. If n equals 1, then 1. By calling these in the order of 1, 2, and 3, and calculating their values in the order of 3, 2, 1, we get the result of factorial of 3 equals 6. By using this recursive way of thinking, complex problems can be simply solved. Note that a recursive program can be called by itself, but during its execution it may not be called by another program. This means that a recursive program is not always a reentrant program.